Hello, welcome again to Block 2, Use of Algebraic Notation, Lesson 5. I'll share my screen. So, in your previous lesson, you learned using letters. So, specifically, terms, algebraic terms, and algebraic expressions being put into a function machine, and then you get an output. You also got up to the stage where you were able to do inverse operation to find out what the input was when you knew the function machine operation and an output. In this lesson, you'll be given algebraic terms as the input or expressions, and then you have an output, but we don't know what the function machine operation is. So we're going to think about that and then find out what the what the function machine operations are. But before we start, you can use 4 minutes or 3 minutes, pause the video, and do the retrieval practice. Okay, I'm sure you've paused the video. You've done the work, you've thought about what you learned in your previous lesson because the retrieval practice helps you to think about all the things you'd learned before. So here are the answers. Okay. So 5H, okay, they're asking you which model shows 5H plus 5. Of course, remember our bar model. 5H means 5 lots of H and then plus another bar which is 5. So this bar is the correct one. The first one you can clearly see we have 1, 2, 3. We have so many fives. Okay, so that won't be right. And then for 2, you're told to work out the output of the function machine. Remember, when we multiply two terms or two letters, we can simply write the letters next to each other. But a proper way to write it is to write it in alphabetical order. So you can see I could have written CB, but it is good practice to write it as BC. Okay, and then this one, you can simply write it as 3x add 5. Okay, let's do some new learning. If I give you this, we don't know what the operation is, but if we think about it as a bar model, we have a B bar, and then if we write this, we now have B and another bar that is 5, which is we've added 5. So if you think about it, the operation that could have taken place in this function machine is to add 5. Okay? So we just figured out what the operation is. What about this one? If we have H and then now we have 5 lots of H, that's interesting. It means we've made it 5 more than it was. And of course, you know the operation that would do that. That would be to multiply by 5. But I want you to think, is there another way? Is there another way that we could rewrite this? So I want you to start thinking about that there is more than one way of figuring out what the function operation is, the function machine, what the operation is. Okay, because I could have written H and then plus 4H. Don't worry, we're going to think a lot more about that. Okay, So here is this one that will really show that it's possible to have two different ways or more than two different ways of completing a function machine or figuring out what the operation was. So if we have 6k and then we have 2k and then we have another 6k and then 2k, there are different ways to think about this. So have a think. Okay, I know what you're thinking. For some people, it's really easy to spot. You may have spot to say, oh, okay, we divided by 3. So you remember your algebra now. You say, okay, we divided by 3. If we have a 6k bar, so we have 6 lots of k, we could split those 6 lots of k into 3 equal parts. Okay, and that gives us 2k each. Or someone might say, no, 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 no. I could just simply take 4k. So either way, we have just used two different ways of getting the function machine operation. Okay? Okay. What we've learned so far is to get the function machine operation, you need to think carefully about what you had before as the input to the function machine that you don't know yet, and what you now have as the output of the function machine. And then you think about what has changed. And then that way you can figure out what the function machine operation was. All right, I would like you to pause the video and answer question 1. You should be able to do this in 2 minutes or even a minute. Okay, assuming you've paused the video, you've answered the question, you're really taking your time to think about it. Here are the answers. So here you can clearly see that we had h before, now it's h plus 5, so we clearly added 5. Here you can see we added 7. So these are really simple function machine operations that we can just put in to see exactly what was done to get the outputs. Okay. Have a go at question 2 and 3. You can pause it. You should be able to do this in 3 minutes. Pause the video and have a go at these. Okay. Assuming you've paused the video and you've really had time to think about this and work through it, here are the answers. Okay, so this is the answer for question 2. You asked to complete the function machine. We can clearly see that we had y before, we now have 3y. So we must have times by 3. Here we had y before, we now have y at 3. So we must have added 3 to y. Okay. And then here you're being asked what is the same and what's different about this function machine. Explain your answer. So here, it involves 3, but the operations are different. So here we're multiplying by 3 and here we add in 3. So they are different operations. And then this is for question 3. Here you're asked to tick the correct function machine in each pair. Okay, the correct one has to be this one. Okay, 2b add 8b can be 10b. All right, so this means if you think about it, about the bar model again, 2b is 2 lots of b, 8b is 8 lots of b, so you can have 8 different bars that are b's and then you can add all of them. But you can't do this to this one because this will be 2 lots of b and then a bar that is just 8. We can't add the bars, you know, they're not the same. Yeah. Then this one is the correct one because you can simply have, this is the same thing as saying you had 2b, but now you have 5 lots of 2b bars. So if you were to draw this out, you have 2b, then times 5 means you've just made these 2b bars 5 lots of them. And then you have, which means you have 10 lots of them, 10 b's. Yeah. And then here, you can't have that. Okay. So 2b times 5b, the correct answer for this one should be 10b squared. Okay. So these are the correct answers. Okay. What about this one? If we have 6c and now we have 18cd, the first thing you will spot is you say, okay, I have 6, now I have 18. What could I have done to get from 6 to 18? If you know your multiplications tables very well, you say, okay, I have just multiplied by 3. But you say, hang on, but this has C and that has C. Okay, but there is no D. Now, if you remember from algebra, when we write things next to each other, letters next to each other, it means we multiply them. So this could simply be to multiply by D. But we're not going to write this. You remember in algebra, we don't write the operations in. We're going to say we actually multiplied by 3D. Okay, we're not going to be writing times D. We'll not write what it actually is. The function machine, the operation is to multiply by 3D. Okay, look at this one. Now, this highlights or this shows that there is more than one way to get the same result. So this could have been to say, well, if I remember, or if you remember, h squared will be h times h. So we could say, okay, the operation is to multiply by h. But someone else could say, no, 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 I think it is to square h. So both are correct. You just need to know that there is more than one way to have the operation of the function machine. Okay, have a go at questions 4 and 5. So pause the video and have a go at questions 4 and 5. So assuming you pause the video and you can work through question 4 for 2 minutes, I'm going to reveal the answer and discuss it. So these you can clearly see. Here we had H before, now we have H at G, so that must be we're adding G. For B, you can clearly see when you write in algebra, when you write letters next to each other like this, it means you had multiplied them. So the operation must have been multiplied by F. This one, it must have been multiplied by Y, because now you have Y squared, or Y to the power 2. Here, we must have divided by 5. Okay, so imagine having 5 lots of P, because that's what it is, 5P. Okay, and then you now divide by 5. Okay, you just have 1P, so you have 1P each. Okay, so your output should be P. Then this one should be 2MR. This one should be times 2B. Because remember, when you have things next to each other like this, you simply multiply them. This one, R squared, now you have R. Okay, so it means you divided by R. All right, remember R squared means R times R. So if you're having R, it means you must have divided by R. And then here you have B minus 2. But now you have B minus 7. So this may be a little bit challenging for some of you, but you need to know that you have an H bar, you have a negative 2 bar. Now you want to take 5 away. So you don't have enough. So you're going to be even more down. So you're going to be B minus 7. Okay. You're going to learn more about operations like this for H if you're not sure. Okay. This is for question 5. You can pause and do this. You should be able to do this in 1 minute. Okay, assuming you've paused and you've done this, here is the answer. You've been asked, who do you agree with? Explain your answer. Of course, run is correct. Okay, because if the function is plus 4h, then we will have 5h plus 1. But if the function is times 5, then it's going to be 5h. So it means you have a bar that is h plus 1, but you're now making it 5 lots of that. So you're going to have 5 lots of h and then 5 lots of 1. So run must be correct, not mo. Okay. Sometimes you have questions like this where you need to start to think, look at more than one output relative to the input to figure out what the actual operation is. So for this one, we can say, yeah, to get from 5 to 15, we're multiplying by 3. But it may not be true when we look at the next one. Okay? You say, okay, if I was multiplying by 3, that should be 30. So you now think again. You say, okay, it looks like we're adding 10. Well, let's check the next one, whether adding 10 seems correct. That seems correct. So if we're adding 10, then we can find the inputs. Remember, we do the inverse operation. Okay? So when you come across problems like this, you need to think about this in stages, really thinking about what you're doing, about the operation you're choosing to use. So if we do the inverse operation to get what was put in, we now have 50, because 60, the inverse of adding 10 is to subtract 10, which will be 60 minus 10, which will be 50. And then this, we can simply write it as an expression. Because we're subtracting 10, we're doing the inverse operation, it will now be 5y minus 10. Okay, so what we've learned so far, before you have a go at the rest of the questions, is that first, you need to think about using operations carefully by looking at different stages of the input relative to the output before you make a final decision of the operation that the function machine is actually carrying out on the inputs. And then sometimes for some of the questions, you also need to do the inverse operation to find out what the input was, like these. Okay, you can pause and have a go at this question. You should be able to do this in 2 or 3 minutes. Okay, assuming you've paused the video and you've worked through it, you've really thought about the solution that you gave or that you've written down. Here are the answers. So here you can clearly see, to get to these from 5 to 15, we're multiplying by 3. And you can see that is the same thing that is happening when you look at the other ones. Okay. So if we choose multiply by 3, you can see it works for the others. All right. Okay. And then this is for B. So here we're dividing by 4. You can clearly see that to get from 48 to 12, we're dividing by 4. Okay. And then you can see 28 and 7. That's another output relative to input that you can look at. You say, okay, it looks like we're dividing by 4. And then when you check, you will see that they are all consistent. That is, you're getting the same, you're getting a result which shows that dividing by 4 is the correct operation to use. And this is for C. Okay, so C is there. You can see it there. B, okay. All right. This is for question 7. You can pause and do this. So here you're asked to complete each function machine in 2 different ways. So remember, there is more than one way to complete a function machine. So here are the answers. So here we can multiply by 3, but then we can also add 8c. Okay, here we can divide by 5, but we can also add 12y. Subtract 12y. And those are the other answers. Okay. All right. This brings us to the end of our lesson. So in this lesson, we have learned that we can find the function operation of a function machine by thinking about really carefully about the output relative to the input. And then we can, after we've done that, if we have a really large block as a function machine, we can think about the other inputs relative to the outputs, sometimes to do the inverse operation once we've found the operation of the function machine to find out what was put in, okay, the input. All right. Until next time, bye bye and take care.